this is the second part of the video lecture B of week 5. In this, we discuss the derivative of the exponential function. We know that there are two exponential functions. One is e to the power x and another is a to the power x. The derivative of e to the power x is same, no change. Whereas the derivative of a raised to x, where a is not e, then it is a raised to x into ln a. It is not I, ln a, that is natural logarithm of a. So let's solve an example. We are asked to find the rate of change of investment where the investment is given in this format, that is Bt equal to 100 times 2 to the power t. This is the exponential function where a is 2. So I will use this formula. Find the instantaneous percentage rate of change of value. The instantaneous means the what you call the derivative. So I find the derivative of this. When I find derivative, I am finding the instantaneous rate of change. So this 100 as it is, differentiation of this, I use this formula, it is 2t ln 2. And if you are asked to find the relative rate of change, so what I will do, I will divide v prime t divided by vt. That means this and this I divide. So in the what you call numerator, it is v prime, that is derivative. So that means the relative change means we are comparing the changes, what happens in there. I just substitute these two, this. So ln 2, use the calculator, 0.693 is the relative change, and this is the instantaneous rate of change. So remember, instantaneous rate of change is nothing but finding the derivative. So we have again some examples on exponential function. Fx is equal to 3ex square. So if prime, so 3 as it is. Now look at it. For this, I will use the chain rule. So what is the derivative of e raised to x square? It is e raised to x square. Then derivative of x square. See, chain rule. So 3x square, 2x is this. So here outer function is e and inner function is here x square. There is a change here, right? So for the second function, there are two functions here. This is the identity function, this is the exponential function. So I will use the product rule. So derivative of x is 1, this is as it is, then x. So now for look at it, for this e to the power 2x, I will use the chain rule. So outer e to the power 2x, no change. Then derivative of inner, that is derivative of 2 by x. So this 2 by x, I bring it up, x up, minus 1. So it is, then I differentiate this and then I bring it down, it is minus 2 by x. In the last example, here also I am using the chain rule. You see, first I differentiate 3 to the power this. So 3 to the power means I am using this, the exponential derivative. So 3 to this ln 3. Look at it here in this case and in this case we have an exponential with base e, therefore no change. When you have a base other than e, then it is the function into ln 3. Then derivative of this. I simplify this. And then the two most important derivative of natural logarithmic function, that is derivative of ln x is 1 divided by x, and derivative of e to the power x is x, etc. That is in this particular format. Same. See, derivative of logarithms. Find the derivative of logarithm x ln x, then ln x cube, then ln x square plus 1. See how we are finding the derivative of this where the logarithms are involved. So f prime x. So this is the power function, logarithmic function. So I will use the product rule. So I use the product rule. Derivative of x 1, ln as it is, ln sorry keep x as it is, derivative of ln x is 1 by x. I have the answer. For this, no product rule because I will use only the chain rule here. So outer function is ln, and then we find the derivative of what? This x cube. So what is the derivative of ln? 1 by x cube. Derivative of x cube, 3x square. So if you simplify this, you will get 3 by x. Or we can find the derivative of this using the laws of logarithm. So ln x to the power 3 means it is 3 ln x. See, I write it here. And then I use the formula. So 3 out, derivative of ln x is 1 by x. So this is the answer without using the chain rule. And you can also do this by using the chain rule. First find the derivative of ln, that is 1 upon x cube, into derivative of x cube, that is 3x squared. Simplify it, you will get the same 3 by x. Finding the derivative of this is not a product, it is a function. You see, function of a function. This is function of a function. This is function into function. Product rule, function of a function. Chain rule, function of a function. Chain rule. So I do the derivative of ln. It is 1 upon x squared. Derivative of this 2x. I simplify it, get this. In this question, you are given Ct 10 upon 9e to the power minus 20t plus 1. You have to show that C prime t is positive, that is greater than 0. So what I will do here is, I will rewrite this Ct as 10, I will keep it as it is. This I will take it up, it becomes minus. So instead of using the quotient rule, you can use the quotient rule also, but instead of using this, let me use the chain rule. So C prime t is this 10 as it is, the derivative of outer, that is minus, see minus this minus 2. So that's why this plus 10 becomes minus 10. So minus 1, minus 1, minus 2. Then derivative of inside one, derivative inside. This is as it is, derivative of this 9 into minus 20, 80, e to the minus 20t, right? And then plus 0. So if you simplify all, you get this. So this is positive and this is square is also positive. Therefore, C prime t is always positive. So we have to determine the concentration of weight never exceeds 10. That means after what you do here is, for this what you call function, we find the limit as t tending to 0 because the concentration increase for all time. So therefore concentration is always less than the limiting value. So mean to find the what you call concentration where it should not exceed any value here. So we need to find the limit of Ct at t tending to infinity. So we write it here and then this bring down. So it is 9 upon e to the power 20t. So when t tending to infinity, 1 by t tending to 0. So therefore this is limit of a constant same, limit of a 1, it is the same, then this limit becomes 0. So therefore get the answer as 10 here. That means you are already given 10 here. So you need to find the limit of this as t tending to infinity. So last, a very important differentiation called logarithmic derivative. So look at it, in the earlier question we have a power function where the base is x, we have exponential function where the base is the power is x, but we have some functions where you have a base also x and the power also x. So look at it, that it is not a power function, it is not an exponential function. So when you have such function where the base also has x, the power also has x, then you have to use the logarithmic differentiation. So here we use some logarithm laws to find the differentiation. So let's take one example for that. Find the derivative of this. So look at it, base x, power x. So no power rule, no exponential rule. So what I will do, the first step is I take ln both the sides. See, ln fx, ln x of x. So since this power, it is always becomes multiplier according to the laws of logarithm. So this becomes x times ln x. So ln fx is this. Then I find the derivative both sides. So here I will use the chain rule. What is the derivative of ln? 1 upon fn. What is the derivative of inside one? F prime x. For this I will use the product rule because it is two functions here. So ln x as it is, derivative of x is 1 plus I reverse it. So x cancels, you have this. So f prime x divided by fx. Then I cross multiply, f prime x is equal to, it is fx into ln x plus 1. This fx is already given x raised to x, I put it here. So f prime x is ln x plus 1 into x to the power x. This is what the logarithmic differentiation to be used when you have a base x power x. So these are the examples where we are using the exponential rules, logarithm rules, and you see all these examples from 1 to what you call 24. We use the logarithmic and exponential rules, and the same using those finding the equation of the tangent line. And here we have again this example we already done, that is in all these four cases we need to find what you call the v prime t. These are the example I already done. So the same it is. See, for this examples we will be doing using that what you call the derivatives again here. And this example are logarithmic derivatives because 39 to 44, where you see the base is x, the power is also has x. So I will be using the logarithmic derivatives for all these functions which I discussed already. Okay, so these what you call examples, I will be taking more details in the live class. And in the meanwhile, you just try these examples here. And here this question number 35 and 36 is the exponential function because it is triples. Triples mean the function will be 200 times 3 to the power t. This is 500 times 2 to the power t because it is doubles. It is triples. So 3 times 3 to the power t doubles 2 to the power t. Okay. In these examples, it is very simple. Ct is given. You are going to find c prime t, and then never exceed means you have to find the limit of this as t tending to infinity. To find this question, so you need to find the limit of this with t tending to infinity. What we have, these are the answers. What we have learned here, how to find the derivative of trigonometric function, exponential function, logarithmic function, and last and the very important is what do you mean by logarithmic derivative? That is the logarithmic derivative to be used when the base and the power has x. Okay, so that's all about the what you call video lecture of week 5. So thank you.